Welcome to Autodesk Simulation TV. We're going to be looking at local coordinate systems in this 2-minute tip. My name is James Herzing and I'm a technical consultant here at Autodesk. Alright, so I think local coordinate systems get a bad name. I think it feels like it's a more difficult task than it really is. There's only a few things we have to do, such as deciding what type of coordinate system we want to define. We're just going to click on the New button, choose rectangular, cylindrical, or spherical, and then define 3 points in space that create the local coordinate system. You can see each one of them even has a picture shown as to where the 3 points actually exist. So in this exercise, we're going to create a cylindrical coordinate system and go through how you select those points. Let's jump into the software and see how we do it. Okay, so here we are in the software, and we're going to define our local coordinate system, in this case being cylindrical, around the hole in our model. Before we do that, let's right-click on Coordinate Systems and click on New and view some of our options. So you can see we have rectangular, cylindrical, and spherical as our types that we can define, and each one of them is going to provide a picture telling you where these 3 points, A, B, and C, need to be selected. First, we're going to give you a little tip here, and on part 2, we're going to define a line across the hole. With that line created, we're going to divide it in half. That way we have a point exactly in the center of the hole. And we can use that to define point A and most of point B for this model. So I highlight the hole, or the node, just to show you it's there. Again, we're going to click on New and change our coordinate system type to cylindrical. The picture updates and shows us where the points need to go. For point A, we click Select A and click on that node on the line we created. We do the same thing for B because we saw that it just has to be along the z-axis somewhere, so we changed the z location from 6 to 9. It could be any other number as well. And then the C value that we selected was just somewhere else on that flat surface. So with that, we can now see nothing's changed. That's because we haven't actually applied the coordinate system yet. We don't need that part 2 anymore, so let's delete it. And now let's select the nodes around that hole. Right-click and choose Coordinate Systems. There. And you're going to see we have a new one, ID1. And that's our cylindrical local coordinate system. You can see around the hole that all the nodes that have this new coordinate system applied to them have the little red line changing direction. So you can see that X is just pointing down in our global coordinate system. Well, now they're radially acting in this local coordinate system. To make this a little clearer, we're going to go ahead and select those nodes again, and we're going to add nodal forces acting in the local X direction. So what's this mean? This shows us that once we put a value in X and click OK, all of our arrows are now pointing radially. So again, if I move, you could see that if it was applied in the global direction, they'd all just be going down, but now they're radially pointing outward. So that's all there is for local coordinate systems. Not really that difficult. Set up very quickly, yet it can have big value for your analysis. If you have any questions on setting this up or any trouble with your models, feel free to reach out to me at the Sim Squad. Thanks a lot.